Okay, welcome to Ideas Foundry again. First video of 2020. I actually thought of this a couple of months ago really, after getting interested in rockets. Me, a rocket scientist, as if. Anyway, as far as I can tell, the biggest problem with getting to orbit is, or the biggest flaw I think of rockets is Newton's third law. Well, anyway, I don't like rockets, but let's see if we can try and improve them. I think the way we're using it at the moment to direct the thrust is a bit barbarically mechanical, with that large bell housing to direct the flow of the thrust. I think using a piece of metal to do that is a bit antiquated. Anyway, so rather than using that nozzle to direct the thrust, I thought of using something else, because at 1 Earth G pressure, whatever, on sea level, the thrust can be like that, but as you get to orbit it expands naturally, so there's not much keeping the thrust from expanding or being more focused, so there's not much required. I don't know the math behind it. Obviously some boffin can work out how much pressure or air pressure or thrust you need working into the main thrust to stop it expanding. But anyway, so I've 3 pages on this. Well, it's a record for me. So it's page 1, so that you can read that. Right by the side of my anti-gravity toilet, but never mind, I don't think they're too related. So, is it overexposing now? So rather than the bell housing, this bell housing here, which is what you could say is normal or typical, this bell housing, that bell housing is normal to the thrusters focused in the direction you want instead of spreading everywhere. Instead of that, I propose I first thought of a fan. So get rid of that completely. Just have something short. That's a combustion chamber, by the way. Get something short here. So without any control, the thrust exiting the combustion chamber here will just go everywhere, uncontrollably everywhere, like an orbit, I suppose. So have a fan around the neck of the combustion chamber, or the exit of the combustion chamber, shown here. Centre of that is the main thrust. And have that neck there leaving the combustion chamber have its own thrust to keep the main thrust in line. I first thought of having a fan going around it, but I don't think a fan might be strong enough. Plus it would need its own power as well. Maybe get some Tesla batteries. Anyway, so that's my first, what I call type 1. So type 2, maybe better. It's 3 types, by the way. Type 2, I thought of, at the top there, type 2 I thought, instead of a fan going around the neck of the exit of the combustion chamber, use rocket thrust. Now this rocket thrust can be from a separate combustion chamber, directed, because it wouldn't have to be too strong, i.e. too hot. So it could be directed more easily than a main thrust. Yeah, or you could siphon it from the main thrust, although you'd run into aerospike problems there, of melting metal being so hot, leaving a combustion chamber. Well, that would be up to the boffins to decide. So thrust controlled, main thrust controlled direction. Something on those lines, anyway. So that's type 2. But with a rocket thrust, especially landing and damn things, we need some sort of control, attitude control. At the moment we gimbal the sort of the main thrust, so as a rocket is landing, its gimbal is moving, well perhaps, I think that's how they work, I guess that's how they work, to control attitude and control of the craft. Obviously, if you're controlling the main thrust by air or rocket thrust, you ain't going to be able to gimbal it, are you? So type 3 solves the gimbal problem. Bigger drawings here. So type 3 solving a gimbal problem would be to just employ typical thrust vectoring controls we use now. That leave a jet plane's thrust engine, which is not that hot. So you'd have these thrust vectoring controls instead of a gimbal to control the thrust flow that controls the main flow. So these thrust vectoring controls can obviously move to direct that thrust whichever way you want. And there we have it. And I call it single stage thrust control because at the moment we have multiple stage rockets because quite simply the nozzle at the bottom at sea level needs to be narrower than a nozzle in orbit to be most effective. That's why it's a single stage. The holy grail. There we have it.